Today we are going to learn how to solve and graph compound inequalities. A compound inequality is a sentence with two inequality statements joined either by the word and or by the word or. Compound inequalities that have an and statement means that both inequalities have to work. And a compound inequality that has an or statement means that only one of the inequalities has to work. Your target today is, I can solve and graph a compound inequality. So let's look at some examples. Our first example is an and statement. And statements can be written two ways. They can be written with the word and, or they can be written as a series of inequalities, which I will show you in the next example. So here's our first compound inequality. It is read, r plus 6 is greater than negative 3, and r plus 2 is less than 12. So what we have to do is solve both inequalities, and then graph them. So to solve r plus 6 is greater than negative 3, we're going to subtract 6 from both sides. So that will leave us with r is greater than negative 9. And now we'll come over and solve the second inequality. R plus 2 is less than 12. So we're going to subtract 2 from both sides. And we end up with r is less than 10. So our compound inequality solution is r is greater than negative 9 and r is less than 10. Now we want to graph that. So we're going to complete our number line by filling in from negative 10 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When you're graphing these, you're allowed to look at whatever snapshot of the number line that fits your solution. So now I want to put an open circle on negative 9 because there is no equal to sign with the greater than, it's just greater than. And then I'm going to come over and I'm going to mark my right bound with an open circle on 10. So now this one says r is greater than negative 9, so that means I would shade all the numbers that are greater than negative 9. And when you have r is less than 10, you would shade all the numbers that are less than 10. So the ones that fit in both of the inequality statements are our solutions. So you can see that we'll have our two bound marks, and we'll be shaded in between when you have an and statement. All of these numbers represent the answers that will make this compound inequality true. All right, let's look at our second example. Our second example is also an and statement, except instead of having the word written, we now have it written as a series of inequalities. When I read this, I'm going to start with where the variable is, and this is 6b is greater than negative 30, and 6b is less than or equal to 60. So we solve it the same way. We still have two inequalities. 6b is greater than negative 30 as our first one, and 6b is less than or equal to 60. So I'm going to write them separately. So I split up my inequality and put my and statement in there. Now I solve both of them. To solve the first one, I divide by 6 on both sides to get b is greater than negative 5. And I also divide by 6 on the second one to get b is less than or equal to 10. So now I'm ready to label my number line. So I'm going to put a 0 here. 1, 2, 3, 4, 5. I only need to see up to negative 5 on that side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on the right-hand side. So I have an open circle on negative 5. I have a closed circle on 10 because I have that equal to sign. So now this says b is greater than negative 5, so I shade in the greater direction, but I stop at 10 because b has to be less than or equal to negative 10. So all the numbers shaded in between our two bound marks are solutions to our inequality, our compound inequality. The last example I have for you is an or statement. We solve or statements the same as and, it's just the picture of our graph will look different. So this is read, v minus 10 is greater than or equal to negative 11, or 5v is less than or equal to negative 40. Again, I solve both of my inequalities. So to solve the left-hand one, I add 10 to both sides. And I get v is greater than or equal to negative 1. Or, to solve the right-hand one, I divide by 5 on each side. And I get v is less than or equal to negative 9. So again, I look at the snapshot of my number line. And I'm going to put 0 all the way down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 will work. And there's 1. I'm going to label every 5. 1, 2, 3, 4, 5. Here's negative 5. 1, 2, 3, 4, 5. Here's negative 10. And 1, 2, 3, 4, 5. There's negative 15. So on negative 1, I'm going to put a closed circle because I have the equal to sign. So a closed circle on negative 1. And I'm also going to come down and put a closed circle on negative 9. So there are my bound marks. Now I'm ready to shade. This says v is greater than or equal to negative 1, so I'm going to shade in the greater than direction. And this one says v is less than or equal to negative 9, so I'm going to shade in the less than direction. Now remember with or statements that only one of these has to be true. So either a number from this set is a solution to the inequality, or a number from this set is a solution to the compound inequality. With or statements, our graphs will always look like this. We will have 2 bound marks and we will be shaded to the outside. So you can kind of compare that to the graph for the and statement. You can see that it will always have 2 bound marks and be shaded in between, and the or statement will have 2 bound marks and be shaded to the outside. Come to class ready with your questions for graphing and solving compound inequalities so that we're ready to practice and do some more examples. See you tomorrow. Bye.